So urban planning program at Columbia has a pretty long history, and of course, digital evolution has a much recent history. And so very quickly, you will see our program is a 2-year program and 60 points, and it's accredited program. And we give students a lot of flexibility. So 27 points are required and the rest are electives, and they can pursue those electives in many different directions, especially in 4 concentrations. So urban analytics as the newest concentration has been a growing set of our curriculum in the last 7 to 8 years. And why do we want to be engaged in urban analytics, right? In urban planning. Urban planning, by definition, is a very much of what we call multidisciplinary field. And we have people from economics, sociology, political science, architecture, geography, environmental studies, students coming from very many different fields and disciplines in their undergraduate studies, and they graduate and also into different kinds of work. Of course, I understand in China that planners are much more concentrated in terms of their types of work, but our graduates really go into many different types of jobs. And so we really feel that we're not really training data scientists, we're not training programmers. We really are preparing our students to know both data science, but also some of the critical issues that planners are very much central to. So our rationales in terms of setting up this concentration has to do with to really look at the role of planning in both the discussion or discourse and practice around urban technology and data analysis. And that includes how do we ensure that different people, different groups of population have access to data and to technology. So that's the inclusion part of it. Second is during the process of planning and using big data, we need to bring in participation and engagement of different groups of population. And last but not least, the outcomes of planning decisions using big data should consider social justice. So I think, you know, for those of you who are planning students or graduates, you know that we are very much traditionally and consistently be interested in the inclusion, engagement, and social justice, and big data enforce those. And so really another rationale for us to focus on urban analytics really for 2 things. One, we want to expand the capacities or capabilities of planners and planning professions, and especially to be more central in the discussion around smart cities, right? Digital urbanism. But we also want to prepare our graduates and students to be able to work in adjacent fields around planning, not just in traditional planning jobs, but also in adjacent fields such as, you know, urban science, urban analytics, and even in some data firms. We do have graduates who do that. So in order to achieve these goals, we have really designed our urban analytics curriculum around 3 sets of things. And the first is what we call knowledge. That is knowledge of planning and policy approaches to digital infrastructures. By infrastructures here, I mean the different platforms, different apps, and different, you know, kind of technologies and data, right? Data. And then a knowledge of how we can manage data, especially in real practices, how we can manage data. And so those are not necessarily you need to do everything, but you know how things are done. So that's knowledge. And then second is that our students really should know how to do some very basic, even intermediate types of data and analytical work, so that they can be in conversation with engineers, computer programmers in terms of working together in applications related to urban and planning work. So they should have the ability to articulate contextual aspects of data, meaning, not just data per se, but how data are collected, what kinds of conditions are underpinning data collection and production. And then also understand the limitations of use of data, right? So data can seem to be rather powerful, but there are many challenges, including privacy, including access, including inclusion, many different challenges and limitations. And then our students should have the ability to develop and evaluate different digital infrastructures for urban development. In fact, for instance, they should be able to design some very straightforward apps, or at least know how to prototype some apps, and perhaps even be able to do some of the algorithm. And last but not least, what we call values, right? And 价值观. That is that data can be used for good and for evil. And anything in between. And so we want planning students and planners to really understand that there are equity and ethics issues in data practices, and that understanding also of how data are governed and how different groups of population can participate in data and communication technology. So using those guiding principles, we've designed a set of courses to help our students achieve those goals, right? And so one set of courses, we call them spatial and data analytical methods. So more what we call 分析方法. So some are related more to spatial analysis, GIS, others more related to quantitative analysis methods, and yet another course on data science methods, actually quite related to the quantitative methods. And then the second set of courses really are about skills, right? Data managing data, machine learning, and algorithms. And so in that, we introduce students to the basic urban data and informatics, and then more advanced version, and then to machine learning. And last but not least, we want students also to be able to apply data and urban analytics in specific areas of planning. Of course, ideally, we want to do everything, right? We want to do environmental planning, transportation planning, everything with some big data, but we haven't been quite there yet, but we are able to provide some courses related to environmental data, particularly related to climate change and energy, and then using urban analytics to make decisions that are more human-centered for communities. And last but not least is type of prototyping, that is to design small apps and to either service communities or collect, say, garbage, recycles, how you can design the data infrastructure and data collection infrastructure to facilitate that purpose. So these are the kind of courses we have in our curriculum. So we are among one of the first urban planning programs in the United States to really delve into urban analytics and big data. So we are pretty ahead in that sense. And last, but I just want to show you some of the work by our students in various data analytics courses. And you can also see we quite emphasize visualization and presentation. That is, you not only know how to manage and use data, but also you know how to present and to have a narrative, to tell a story, and to convince your audience, right? So here is advanced spatial analysis in terms of looking at social vulnerability in flooding. This is New York City. And then this, you can see that our students use data analytics and visualization to portray how homeless problems are present in New York, actually not New York City, this I think is, Los Angeles, I think. I'm not 100% sure, actually. A couple years ago by our students. And then this is also students using big data, tracking how women cycles or using bicycle in New York City in different types of time and for different purposes. And the way that they present data is quite impressive. And this is using more of environmental data to look at how sea level rise would affect in different scenarios New York City in terms of if sea level rise is at certain height, how the Lower East Side of New York City would then be affected by flooding, right? So you can see the simulation in there through the slides. And this is prototyping, that is students are trying to figure out how on campus and around campus they can collect compost, and they designed this app. I'm not sure some of the students actually know how to do the program so that the app actually is usable, but at least they know the different iterations towards that purpose, and they have an architecture of the app pretty much set up. And then last but not least is students also in the past were able to learn how to use sensors. So they have designed a number of sensors to go out and collect data, and then subsequently bring the data back to analyze in terms of air pollution and noise and so on in New York City. So that course we've been offering a couple times and hope to offer it more often. So with that, I just want to say, you know, in planning, there is a lot of really productive use of big data in different ways, and there are knowledge, skills, and value to be learned in a planning program. And I hope our panelists in the next half hour or so will illustrate some of the practical issues that come out of the using big data and urban analytics. So with that, I will stop sharing, and thank you very much.
Yeah, thank you, Wei-Ping, very much for this opening remark and the introduction to the urban planning program at GSAPP. I just saw a question in the Q&A part, and I think maybe you will be interested in answering it. The question is why the Columbia program, I think the urban planning program, is not STEM certified.
Absolutely. Yeah. So I guess, yeah, that's a question that's been asked by many students. STEM in the United States by the Department of Homeland Security has basically a set of what we call classification of instructional programs, CIP codes. And so all of the city planning programs use a certain CIP codes. The city planning CIP code is not on the list of STEM fields. So you might have learned that there are a number of planning programs, about a dozen of them in the United States are STEM programs, because they are no longer using the CIP code of city and regional planning. They've switched their CIP codes to either sustainability science or management science. And so at Columbia, for us to be able to switch that CIP code involves substantive or substantial change in the curriculum, which actually needs to be approved by the state and many different things. So with that, every university does it differently. Some universities make the CIP code change quite easy. And so every state does it differently in terms of control of the use of CIP code. At New York State, it's actually rather difficult. And so at Columbia, so we haven't been doing that because of all of that that's involved. And I can also tell you, because of my involvement in the city planning field, that generally overall the field is very divided in terms of whether we want to abandon the CIP code and then just moving on to a different field. So that's a pretty quick answer. I also wanted to really quick to say that whether digital should be 数据 or 数字, the reason I use 数字 actually is a little bit choice, a conscientious choice, because if we look at data, it's not just numbers. Data also include text, right? We know there are lots of digital text analytical tools. And so I think it's really more inclusive to say it's shoots. So there's the numbers, there are the texts. So yeah, somebody was saying Binda. And so University of Pennsylvania, the planning is STEM. They have changed their CIP code to sustainability science. So they're no longer CIP code planning. Yeah.
Yeah, thank you very much for the explanation. So now we will move on to our panel, Urbanization of Post-COVID China, Big Data and Response Mechanism. We hope that from sharing our knowledges and experiences, we could better engage the next generation of planners and designers. This panel is also a continuation of our year-round dialogue with respect to urbanism in post-COVID China. And mid-April this year, the Urban China Network launched the student initiative, Urban Reflections on COVID-19. I would like to express my appreciation to all our panelists, Helena Ronghang, Gu Peijin, and Liao Yang. So your willingness to share your knowledge and experiences and your willingness to contribute your time to really make a huge difference for us. I would like to have our panelists introduce themselves to our audiences. And I guess I can start with Helena.
Okay, great. Hello, everyone. Very happy to be here today as a panelist. Thank you so much for the invitation, and thanks, Wei-Ping, for the opening remark and Shen-Xin for the introduction. So my name is Helena. I'm currently an urban planning PhD student at Columbia GSAPP. My work lies at the intersection of technology, design, and urbanism. And prior to coming to Columbia, I've worked as a researcher at multiple research labs, including the MIT Real Estate Innovation Lab, the MIT Sensible City Lab, and the Urban Risk Lab, which allowed me a lot of opportunities to work on various projects that were exploring these intersections. And originally, I have a background in architecture and urban design, previously having worked as an architecture designer at firms at various scales in the Netherlands, New York City, as well as Shanghai. I'm currently also running a small design and consulting practice based out in Boston and Shanghai that explores the potentiality of employing new media and IoT digital technologies to designing the built environment through combining design with research. I'm very much looking forward to today's discussion with you all. Thank you so much again.
Oh, thank you so much. Peijin, would you like to go second?
Okay, no problem. My name is Peijin Gu, and thank you for the invitation to the event, and Professor Wei-Ping, long time no see. And I'm graduated from GSAPP from 2014, and after that I worked in Energy Foundation for 2 years and in CSTC. And then in 2017, I co-founded City DNA technology with some of my partners. And from then on, I was working as the CDO of this company, and I was in charge of the overall product design and the delivery of this whole company. And my main field is in urban health check and TLD design and the employment of the AI technology relevant fields.
Okay, so let's move on to Liao Yang.
Thank you, guys. Thanks for the invitation and the introduction. So I might be the only one still in the field of planning. I'm currently the planner in Shenzhen Urban Planning and Design Institute. And before that, I had 2 years working experience in Gensler in LA. Also doing working as a urban designer in the group of city and urban planning. And I also have the background of architecture and urban design. Through all these years, I have been working on different scales of urban design or even some planning. So I'll be very interested to talking about big data, like how can they be applied in my field, the urban planning field. So looking forward to these topics.
Great. Thank you, everyone, for the introduction. Let's begin this panel. So our panel will focus on 3 topics: spatial planning and urban density, big metrics and data diagnosis, and technology and urban management. We hope to facilitate an exchange of thoughts between our guests and our participants. I would like to start our first topic, spatial planning and urban density, by asking first Helena a question about your research. So do you have any research to share with regard to urban density and COVID-19?
Yeah, sure. I'm happy to share some insights on this topic from this paper I was actually working on for Wei Ping's class during my first semester at Columbia. So as we know, in the past, the urban density has always sort of been purported as the driver of economic development and innovation due to its ability to generate agglomerations of capital, diverse services, and talents, which essentially would make cities more efficient and more sustainable. But as we know, COVID-19 is a respiratory disease that spreads based on human-to-human contact. And so many observers are contending that higher population density are more vulnerable to epidemics due to their higher chances for crowding and interpersonal contacts, which is, fair enough if we think about it sort of based on common sense. And then the question really becomes for planners, does urban density aggravate the spread of COVID-19, and should it be encouraged in future developments as we move forward? And I think to answer this question, we first need to define what we mean by urban density and how it's measured in both practice and research. So in recent scholarship throughout last year, there has been a huge debate about whether the relationship between COVID-19 and density is positive and significant, or whether COVID-19 is impacted by density at all. So, for example, an analysis of 13 districts in Wuhan find a positive correlation between COVID-19 and population density. But on the other hand, another research also in a Chinese context that studies 240 Chinese cities find that cities with high population densities actually are correlated with fewer confirmed cases, while cities with lower densities are found to experience the highest COVID-19 infection rates. And then another study in the US on 900 counties, they don't see a relationship between COVID-19 and density at all. And they actually find that COVID-19 has a negative correlation with COVID-19 death rate has a negative correlation with density. So, there's a lot of divided opinion, and even now there's not really a consensus among scholars on this relationship. So I think that, most of these studies are using multivariate regression analysis on different cities that measures density at the city or regional level. So typically, the formula is simply population over land area. And despite using the same empirical study methodologies as I mentioned before, they're not able to reach consensus. So why is that? And I think that the answer has to do with the unit of analysis that's been chosen for each study. And simply because it's the unit of analysis right now typically used is too large to draw any meaningful conclusions. So in a short video by Professor Shlomo Angel from NYU, he has defined urban density by breaking it down into more refined componentries. So it's actually not as simple as population over land area, but it's actually consisting of much finer grained factors and characteristics. So for instance, typically we understand it as population over land area, as I've mentioned. But looking at density at the scale allows us to only understand larger economic patterns and trends without really looking into the finer grained neighborhood scale characteristics, which would be more meaningful, as we study something like COVID-19. And so Professor Angel is saying that density is broken down into smaller components. So for example, FAR, floor area ratio, which has to do with floor space occupancy and floor area density. And these things are things that we study at a building scale or neighborhood scale. So that's the super interesting video on YouTube that explains all of this in more details for anyone who's interested. But basically, my point is that understanding density in this way allows us to zoom in and study at the scale of a neighborhood and of a building, which is much more meaningful to drawing conclusions about the relationship of COVID and COVID spread between people at a mere distance of 6 feet, right? So this would allow us to understand it better, its relationship with urban density. So really, this relationship becomes very complicated as we move across different scales, and is really determined by the unit size of the study on different areas. So some strategies that have been identified as effective in managing density on a smaller scale includes using smart technologies, which relates to today's topic, such as contact tracing and big data to track the spread of diseases in hyperdensities, which we're all familiar with in China by now. But this has been, critiqued for maybe infringing upon data privacy and these sort of issues, which in the more democratic societies, people have more oppositions against. And then another strategy is deconstructing density at the local scale to make more walkable cities and to really redefine the scale of cities, such as the 15-minute city, which derived from Paris, that would prioritize pedestrians and bicyclists. And then there's also discussions about reducing density by mitigating crowded living conditions in informal settlements, so such as favelas in Brazil or Chenzhongcun, urban villages in China. So, there's a lot of work that can be done in this area for urban planners and designers. But I think the overall key takeaway for us is that designing future pandemic-proof cities is not as simple as should we densify or de-densify our cities, but rather I think it's a question of really bringing more effective management of density and targeted solutions on a case-by-case scenario to localized issues that are looked at higher resolutions. And of course, this can take advantage of available tools and technologies, as well as data analytics.
Yeah, thank you for sharing this research. Do our other panelists want to jump in?
Yes, so for the COVID-19 and density question, below that scale, I want to talk about the urban village in Shenzhen, because in the post COVID-19 period, actually the fences are still there, and there is a report shows that the urban villages in Shenzhen is actually not that planned in the whole city, but they probably the most vibrant area in the whole city. But due to those fences, the stores and all the mechanism, the influence by the COVID-19 to them is just crucial. So to my experience, we did some workshop to discuss about this. If big data can do something about defining the boundary that should be fenced, you should not block the way of people doing business every day, and if you can, we can use those data to really define the boundary and the routine to understand how people, residents in that neighborhood, how they work, how they doing their own stuff. So I think that might be what that's what I'm looking for, the big data to deal with the COVID, post COVID-19, the smaller scale units.
Actually, this question is very complicated. Actually, I prepared some of slides and share here. Actually, I very agree with Lina's point, because urban density is really a very complex issue, and corresponding to different circumstances. Sometimes we think that urban density is good, and sometimes urban density is not good. And in 2016, we evaluated the TOD indexes in China, and then we found that a lot of the development around the TOD stations are still not good enough. And then all of a sudden, in COVID-19 camps, and a lot of the debate was going on that whether density good or not. And so in last year, actually, we evaluated all the urban density level in 36 countries. Some of the slides here showing we do the urban modeling, and then we calculated this kind of indices like the development density, and then let me jump to the last slide. We found that actually we have some kind of this range to indicate that we think the density between maybe 1.2 to 0.8 watt per kilometers are more suitable for this city. Maybe because over this range there are some of these services were not providing enough and kind of these services for them, and lower than this range, maybe the this kind of the effect of concentrating this kind of economic development are not good enough to support the urban development. And then if we see through this question more systematically, we will see that a lot of development density in the central city area are too high, but in some periphery areas, the density are not enough. So maybe we can see through this question more systematically. They will help us to understand the question of density better. Thank you.
Yeah, so yeah, it seems that even for like density, there are different ranges of densities. And I have a quick question with regarding the what Peiting had just said. So what is how are those densities measured? Like what kind of unit are those densities measured upon?
Urban modeling is built upon every single building. So this unit can be calculated in different kind of level, whether for the building or for the block. We measure it in FAR, or we measure it in some neighborhood or up to the city. That's all doable.
Yeah. So we have. It seems like we also have a question from the live streaming platform. So, what is the with regard to the sample cities? What are the standard for choosing them?
The sample is not set by us; it is set by the administration.
Thank you for answering those questions. We can move on to the second research. Beyond urban density, there are also all different other type of factors that could contribute to neighborhoods' vulnerability to COVID-19. Helena, you talk about neighborhood characteristics are very important to identify neighborhoods that are more vulnerable or more at the risk of COVID-19. And would you like to talk about what other factors other than urban density that may also kind of contribute to that as well?
Yeah, of course. So I got to work on a project last semester using machine learning to diagnose clusters of neighborhood characteristics during COVID-19. And right, so we find that at least in the context of New York, which was the geographical area of our study, at the zip code level, COVID-19 is correlated with many different factors. Besides density, some key factors including politics, percentage of Biden versus Trump votership, and also socioeconomic status, whether there is a high percentage of vulnerable populations such as elderly population, or racial minorities, Black population or Hispanic population, and also the nature of employment, right? So whether the job allows the people to practice preventive measures such as social distancing. We know that essential workers are not really able to like stop their job or work from home during this time. So they had like greater exposure to risks during this time. So that was also like really relevant in the spread of COVID-19. And then lastly, also like social distancing practice, both from an economic and cultural sense, like whether people were able to and willing to practice social distancing, which was, you know, like something that people were never used to before this pandemic happened. And what we found was that some neighborhoods, such as the Lower Manhattan, despite having high density, they actually observed low death rate and quick recovery rate. And if we look at other neighborhood characteristics, we can quickly find out why, because these neighborhoods tend to be characterized by wealthier population, younger population, and also greater access to health facilities and testing stations. So, you know, like COVID-19 as a, I guess, in quantitative like analysis, as a dependent variable, it's associated with many, many different factors that all sort of contribute to whether like it would mitigate or exacerbate its spread.
Oh, yes, for sure. I'm very curious, when ctDNA produced like those urban diagnoses for the city governments this year, were there any indices dedicated to pandemic response capacity, like definitely other than urban density?
I also prepared small slides. In last year's urban health check, actually we selected several indexes that was corresponding to this question. I think there's 4 indicators that was directly answering for this question. The first one is the hospital coverage rate ratio for those cities. And we can see a lot of the situation shows that even in some big cities, there's not enough coverage. For example, in Guangzhou, in Chongqing, and Xiamen, you can see the hospital coverage rate is not good enough. And then the second indicator, some of the people were suggesting that this kind of this indicator will have a suggested range around 80%. Actually, a lot of cities are not doing very good enough. And the third one, third indicator is like in a city, maybe we have this kind of big public building that can be transformed in some emergency handling functions. And we also have a value that was suggested for these cities. But actually, we can see over 75% of those cities are not doing very well in this indicator. And last one, there was the indicator that are measuring the centralizing ratio of this kind of traditional or very this kind of market with very bad built environment. And then we can see in Urumqi and Puhao and like in Xiamen, this kind of ratio is very high. And then if this ratio passes 70%, we will evaluate them as a high risk because we can see in last year a lot of those public examples are found in corresponding to this kind of traditional market. There was some indicator I can share about this issue.
Thank you for sharing those indicators. Yeah, I would like to ask more questions about the processing of data. So Helena, you mentioned that you deployed machine learning algorithms to study the correlations between those factors and neighborhood vulnerability. So would you explain in very plain language what machine learning is and how is it kind of used in your research?
Yeah, sure. So simply put, machine learning is a branch of AI and computer science, which focuses on the use of big data and algorithms to sort of imitate the way that humans learn, gradually to improve its accuracy. And by data, it encompasses a lot of things, such as numbers, words, images, clicks, you name it. And if it can be digitally stored, essentially it can be fed into a machine learning algorithm. And in our everyday lives, machine learning powers many of the services we use today, such as recommendation systems. So Netflix, YouTube, Spotify, based on user preferences, and also search engines, so like Google, Baidu, or social media feeds like Instagram, and the list will go on. And machine learning can either be supervised or unsupervised. Supervised meaning that you have the known input-output pairings, and you're training your algorithms to essentially learn from historical data in order for it to be able to make future predictions. Or it can also be unsupervised, which means that you sort of learn about and recognize patterns on unsorted data in a black box condition. So the algorithm would, in the end, would like give you groupings of different data that it recognizes as being similar. So that's just sort of like in a nutshell of what machine learning is. And in urban planning, it has been applied more and more in recent years. As urban data has been like collected in a much more systematic and efficient way. So for urban data, we could be talking about, like administrative data, such as transactional surveys, including land use data, tax records, annual reports, budgets, or it can be user-generated data. So social media data, like the traces of information that people leave online, both knowingly and unknowingly. And finally, also sensor-based data, so including remote sensing, such as satellite imagery, or in situ sensing, such as air quality sensors and public Wi-Fi, which are essentially become like very much embedded in our built environment. So like when we walk on the streets, like basically there are a lot of devices that's built, whether visible or invisible, into the environment that's learning about what's going on in our cities in real time. And applications of machine learning in urban planning has also been widely explored in recent years. So including, like transportation planning and traffic analysis and predictions, environmental sensing, and also mapping terrestrial ecosystems, studying neighborhood characteristics, as I have mentioned, and etc. So it's really becoming like a really like large topic that more and more practitioners and scholars are contributing ideas and research to. And fortunately, Columbia is actually among the institutions in planning in the United States that's like putting a heavier emphasis, as Wei Ping has mentioned before, in this area of study. So for those of you, the incoming students who are interested, there are a lot of great courses offered at Columbia on data analytics that would employ like machine learning techniques, both like inside and outside of GSAPP. So it's an exciting time.
Thank you. You mentioned that in the previous research that you used like clustering?
Yeah, so actually the previous research we have done for like a machine learning course essentially was using like a combination of different methods. So firstly, we have like done a k-means clustering, meaning that we have a series of data that's sort of unsorted and we don't really know like what the patterns would be. And we fed it into the machine learning algorithm. And the input data we used were the time series data of COVID-19 infection rate. So that was measured on a, I think weekly level basis. So in the end, what the algorithm has done was essentially based on like we specified that we want, say, like 5 groupings. It would group the unsorted data into 5 groups based on like what the algorithm understands as displaying similar characteristics. And obviously, like once we have the groupings, we need to understand like what different neighborhood characteristics they were embodying, and within these groups, like what are some similarities and differences and patterns that we can detect to essentially like understand what each group means like more intuitively. And so like after we have the groups, we then did an Anova analysis, which is to study like the average like mean and variance within each group, the different neighborhood characteristics. And then after that, like we observed some patterns, we also ran a regression analysis to see like whether there was a significant relationship between COVID-19 and the indicators that we thought were contributing to COVID.
I think the application can be seen in every in a lot of aspects because data is become a very important production element in the planning field. So actually, I also have a very small slide. I'll show a very quick example. It's long, but I will go over it in 2 minutes. It's an example that I use machine learning and image detection technology in this topic of street health check. And actually, I select in this project I selected 26 neighborhoods in 4 cities, and quick. And then actually I use remote sensing detection technology to detect all of these buildings, and then we use one of our product things away to collect those image data, and then we applied it with image processing technology to get those indicators in these images. And the first aspect is safety, and actually we measure it's showing this PPI, I don't need to say. And then all these indicators good with feature it with green light, and then whether if it's bad, it's showing red. And we can see in Wangjing, the pedestrian width it is very good, but if we see in Shenzhen, the performance is very bad. And also we can see the here. Okay. But we can see those this kind of technology can help us to break down these indicators into a very detailed level. Like this legend show that there is no illegal parking in these areas, but in Beijing there's lots this kind of illegal parking in those hutons. And in there's one more slide. I think that is very interesting. This kind of chart indicates there is not shows that the pedestrian footpath is broken here, and then you can see in Shanghai, the broken point is very less. And in Beijing, Sanliteng, there's a lot of broken points in this table. And all of these indicators are all calculated using machine learning and deep learning algorithms. So this example shows how it can be applied and help us to diagnose this kind of urban problems.
Yeah, thank you. Liaoyang, do you have any comment on how designers or urban planners can kind of use this kind of product to help with design?
Yes, actually, I just add on to Pei Qing's slide that we always found that the data provided the products they provided that doesn't always match what we need, and the city, the urban environment is always dynamic. It's changing continuously. So sometimes the data is from 5 years ago cannot really help me in the current issue. I want to ask you these two other panels. How is it how is the technology being evolving to be real time?
I think in last few years we rely heavily on open source data that we can collect it for free from the internet, like Baidu and Google imagery, this kind of free data. And then we also confronted the same kind of question that was asked by Yao Yang, because this kind of data are not very up to date. Like in Baidu street imagery, the latest we can get is in 2019. So we found that if we want to get this kind of real data that was up to date and is good for use in the project, we have to collect them by ourselves. Yeah. Unless there are lots of in some area that was built on the new the standard of the new this kind of digital or data infrastructure that provided enough kind of sensors that can for example, in transportation field, there's a lot of sensors like cameras and this kind of Bluetooth sensors that can provide enough data for us. But in general speaking, in urban design or urban planning, the infrastructure is not that good. Yeah, so we still rely heavily on this kind of manpower to plan on site.
Of course. And add on to the clustering of data that Helena just mentioned. I also have a question about, like, if the AI is smart enough, can it like bring up some questions that we never thought about when we are doing the urban design to solve those like urban issues? Is it possible, like based on the technology, like nowadays technologies?
I think the application of AI in urban planning and urban design is still in a very low level, like in the very preliminary stage. It can in the other projects and situation I see, the application of AI is like help us to develop this kind of indicators to help us to understand the city and understand the problems. But in some cutting edge fields, I think in MIT, there are, and like in some of those laboratories, I know there are still there are people that was testing to introduce the AI to help us to design, but still it is also in a very preliminary stage, because it help us to produce this kind of combination of streets and buildings, like it was generated by AI, but it also it was mimicking those plans we did before, and under most of the circumstances is not good enough, because I think the AI in this moment is still lacking this kind of sparkling moment that will really generate those design that will impress me. I haven't seen them, and maybe urban design because AI it relies a lot of this kind of training materials or assets. There is not enough design assets in internet or in everywhere in every design companies. This sharing space, they are not enough for those AI to learn.
Okay.
Yeah, that's my understanding. Thank you.
Yeah, and sort of just to add on that, I think machine intelligence is not going to replace human intelligence in the short term. I know there's a lot of news articles or like hypes about whether designers will be losing their jobs because AI is so advanced and it can basically do everything, right? But I think, as Pei-Ching mentioned before, there's a lot of limitations as to what machines can do. I think obviously machines are good at certain things, such as like producing repetitive tasks in a much more like faster and efficient way. but in the end, like to evaluate whether like the outputs are really the optimal ones that can be used for like design decision making or planning decision making process still requires a humans to like sort of evaluate and compare it across like different like other conditions, such as, you know, like cultural context, social context. Like these things might not be something that machines are salient of, depending on what inputs have been given to it. So I think like there's really this sort of collaboration relationship between humans and machines rather than like a replacement sort of thing.
Yeah, we just spend a lot of time talking about like machine learning and artificial intelligence. To maybe move on to like other technologies as well, other than just machine learning and AI. Those technology developments also like create opportunities for really governments to adopt like smarter solutions to urban issue. Let's start with Helena, and if you can share maybe like a project that shows the potential of like technology and urban management.
Yeah, sure. All right, so I'll be sharing about a project that like my practice has been working on for the past half year. And it's a project sort of relevant to all of these things that we've been discussing about today, you know, like design, urban planning, use of big data, etc. And also like it's focusing on a specific site in a Chinese city. So it's a project that we are collaborating with the local government in a small city in the Hunan province on the topic of street vendors economy. So for those of you who haven't heard this term before, street vendors economy or 小店经济 has been a term that's been popularized last year since the pandemic, when, you know, like a lot of small businesses and street vendors have been impacted heavily by the pandemic. So it was the Chinese government in response to these issues and a refocused attention on such activities. So after the COVID-19 pandemic last year, in order to bring the derailed economy back on track, most cities in China have adopted the street vendors economy that would encourage ordinary people, such as the people who have retired or low-income communities or people who are like university students, to set up vendor stalls on the street and sell various commodities and food. And previously, these activities have been sort of not really being legalized. And whenever you know, like a street vendor is selling goods in an area that's not like where they're not allowed, they will quickly be shooed away. And it's sort of like an underground activity that's been going on in the past. But however, the government is realizing that they are actually providing temporary employment opportunities during times of crises, such as the pandemic, and, you know, like bringing in short-term economic remedies for many neighborhoods across China during times like COVID. So it's an activity characterized by low threshold for entrance and also low sunk cost, free operation, as well as lack of supervision. For us, our task was to come up with a system that would support street vendor economy in a pilot project on one popular pedestrian street in the city. So as you see, it's the area that's circled in red. Yeah, the city is called Lodi in China. And basically, what we have done was essentially designing a systematic solution to facilitate street vendors economy in a much more sustainable way and also legalized manner. So our project had 3 components, which incorporates both online and offline parts to it. Firstly, we're designing a feasible guideline and master plan of creating flexible market layouts that fit the use of vendor stalls. And then secondly, zooming into the product level, we are actually designing and prototyping the street cart itself, which would be multifunctional, that would, you know, change into seatings when it's not in use, and also be equipped with sensors so that it's collecting information on the urban environment. And lastly, we are also building an online platform for relevant stakeholders. And the 3 types of stakeholders we identify include vendors, customers, and management entities from the city government. Yeah. So the online app will be collecting data on business operations and also help management to sort of learn about the status of the vendor activities, such as which vendors are doing great business and which ones are facing like economic like difficulties or declines that might need more help. And also, it would facilitate the application and approval process to become a street vendor so that the activity is much more accountable and secure, as well as, the process would be efficient and also institutionalized. And then at the same time, the app will also provide information on real-time traffic that shows the level of crowdedness. It will display the business map for visitors for navigation purposes, and also advertisement opportunities for the street vendors so that they have a channel to promote their business and communicate with customers. As these people are currently not, part of popular apps used for this purpose, such as 大众点评, right? So we're like also incorporating that function into this online platform. And then finally, vendors will be able to reserve their cart using the app, assuming that not all vendors are like practicing day-to-day business. Maybe it's just a weekend that they need the space, or maybe it's just like a select period of time, like during the week. We don't know, right? So we wanted to like design the system so that it's flexible enough to accommodate all of these changing and transformative practices. And we can sort of like think of it in terms of a shareable carts, like we work for street vendors sort of thing. So these are just some imageries on the on the design of the cart. Actually, we managed to prototype 6 carts as the first like pilot study, and it's actually already in use right now by the street vendors. Yeah, some glitzy renderings to show like in an ideal situation what this would look like. The Wechat mini program, which hopefully will be launched in the next month or two, and having all the functionalities that I have just mentioned earlier. Yeah, and the main functions, reserving for cart usage, navigation and event discovery. And we actually wanted to like explore potentials of incorporating technology such as AR to make the experience even more interactive and also fun. And essentially just browsing the real-time map that would reflect, like visualize and reflect the data that's been collected online and offline. Yeah, that's the last slide for me, just this short presentation. But essentially, I think a takeaway for us during this whole time of doing this project was that to achieve like truly equitable design of public spaces, we think that it requires not only creative solutions to inclusive spatial design, but also innovation in the design of institutions, which would remove biases and prejudice against marginalized groups, in this case, street vendors, so that previously prevented them from rightfully participating in the use of public spaces, and now like really incorporating them as key players into the urban environment.
I think there's one like questions from the chat with regard to the use of technology. So like, will there be a group of people, for example, that are not familiar with like smartphones and like those kind of applications, and how do you work with them?
Right. Yeah, this is a really excellent question, and this is also something we were considering at the start of the project as well. But luckily, like in China, like it's really surprising to see like the penetration of programs such as Wechat and also Wechat mini programs have been so deeply ingrained in the society that actually, like I think the majority of people would be really quick to learn about using these technologies. But of course, there's also like people who like, especially elderly population, who might be less educated. So I think for us, it's really a process that would be iterative, right? So we design the app. We will go on the site to interview people to get their feedback and to see whether everyone who's on the site are actually using it and whether they find it to be successful. So we think that it's not going to be just a one-time shot, but actually it's like a continuous process where we receive feedback, and it's like many times of iterations that hopefully would eventually improve and optimize the usage of the app, and also allow us to learn, like what can be improved and what can be like, which ones, what are some misalignments from what we initially anticipated as designers. Because an interesting fact, like I was showing images for the streetcars previously, right? So recently we went to the site and took some photos to see how people were actually using the products. So originally we had like sort of this additional element in front of the cart that we imagine to be seating for people who are like not using the cart to sell goods. So when it's not being used, we imagine that it could be part of like an urban furniture, and that's part of the plaza. But actually, like the street vendors are almost using the carts for vending purposes the entire time. And then they are reappropriating some of the functions that we thought to be used for certain purposes, but actually like adding additional elements and attaching like, you know, things like frames or like additional platforms in a very ad hoc and tactical way. So yeah, like for sure, like on-site visitations to evaluate the post-occupancy and usage is very crucial for us, as well as educating people who are not familiar with using these products.
Yeah, so like what you just said about like the ad hoc way of appropriating urban space actually also remind me of the like urban village that we also talked about like a while ago, about like how like urban village is also like sometimes seen as like an informality down from below way of really like using urban space, not necessarily from use it in a way that like the top-down planning actually are doing. Yeah, so I think it's just like very interesting way that like how technology can actually captures all those like nuances and differences we are actually using the space. Any comments from like our panelists?
Yeah, actually, I think the proposal that presented by Lena is very interesting, fascinating, and I think that maybe to draw more people views, we need an example. Maybe in the first stage, it is not the ideal enough to attract a lot of people to use the mini avenue design, but we can use some partnership, because you are also doing this kind of consulting work. Maybe I think maybe you can establish some of this partnership with some of those real estate developers to actually develop an example that was ideal enough to let those vendors to see, wow, using this mini app, they can achieve this kind of effect. I think the example is more powerful.
Yeah, I think Peiqi mentioned like partnership, which I think like for a lot of projects that do incorporate the use of technology, you know, like smart city projects, really relies on like effective public-private partnerships, because you know like there's just too many stakeholders that's involved, and you know, to facilitate and just to communicate across different stakeholders, we rely on some sort of institutional setup that would ensure that all the like, you know, helpful content of information are passed on to the right people. So yeah, like that's also kind of our takeaway from this project as well.
Okay, cool. So we can open up I think this is like very much the end of our like conversation. So if, like, do anyone have any comments or questions?
Yeah, we have a question here as like, how do you think that in the future that the urban technology may influence the like urban form, and also how can it contribute to like the overall welfare of citizens?
It's really very simple. This shows some of the pictures that I took in China. And a very huge screen that shows all kinds of this IoT data that was uploaded in Chengdu. You can see the person is very small carrying this screen. And this one is somebody sent to me last night. It is also a monitoring system in Guangzhou, Beijing Road. I used to work around this area when I was studying Shenxing University in Guangzhou, and there's no this kind of thing at the time. And this is also a monitoring system developed by by our team is installed in Jinan. Also, this another novel. So this few examples showed. Okay, that's all. And my point is that this kind of digital revolution is going on very enormously and unimaginably in all about China. And so I think this process will continue in the next decade. So I think this kind of new technology will help the governors to, in this stage, they are providing this kind of data sensing technology to them, and then help them to understand a lot of the question from this kind of live data stream. But in next field, I think the development of AI technology will help them to in the decision-making level, but not only in this kind of monitoring level. So I think urban planners has a lot to do in next decade under this kind of type.
Yeah, and maybe just to add a comment, like we're talking about COVID-19 and cities today, right, as the main topic of our discussion. And I think like this pandemic has really allowed some technologies to emerge during this time that facilitates like the way that we live, the way that we work in a much more like virtual manner. Like today we are still using Zoom for this panel discussion, even though China doesn't really have travel restrictions anymore. Like we could have just, like all be offline and have everyone together, but now we do have the technologies to connect with more people using these new tools. So like I've heard someone say before that Zoom is not just going to be a work from home like app that's been used like during the pandemic, but rather it's something that might be like a tool for work from anywhere that continues to stick with us for like future times, as even when the pandemic is over, hopefully soon. And like I think all of these implications, because this is all like very new, so it's hard to say for sure that what kind of impact it would have on the urban form. But just to think that people can now connect with each other much more efficiently and easily from anywhere across the world might have some implications on the urban form. Like, are we going to have like CBDs in the future, or can we have much more integrated and mixed use communities because people are now more flexible? So I think that these are interesting questions onwards for urban planners and designers to see that, like, given the available tools even we have now, can we imagine cities in the future to be different from what we are familiar with? Yeah, so it's interesting to ponder, and definitely going to be topics of interest for us down the road.
Yeah, thank you all very much today for sharing this with us. Thank you for sharing your experience, expertise with us. And thank you everyone for participating and contributing your valuable opinions and comments to our discussion. I also want to say, like, thank you to the staff of the Columbia Global Center for all the support. And thank you our sponsors and everyone, including our members of like Urban China Network, who made this all happen today.
Thank you.
Thanks.
Thank you. Yeah.
Thanks, everyone.
Thank you.
Bye.
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 Good job. Bye-bye. Bye-bye.